which is mostly behind us and going northeast from us. It's a pretty big patch of it, typical non-vegetated, really bare, rounded kind of hills. And I'm not sure, everybody can see the little map. I didn't have, my big poster my printer broke down when I was trying to print this poster out. And so at that point, I gave up. But we are, I don't know how many of you can see this little map. Oh, it may not, you can't see it from here.
Perfectly.
Yeah, we see some yellow
Yellows,
and
red.
Okay, yellow is the
Some
granite
lines.
Mount Scott, and red is the Fort Sill, Carlton Rhyolite. The really big patch is the Rhyolite in Fort Sill.
yeah,
And you see that big patch?
yeah.
And then you go across a big diagonal line, that's the Mears Fault.
Okay.
And then north of that, there's little blue patches. Those are the Cambrian Ordovician sedimentary rocks, all tightly folded, deep to
See
hell,
those?
basically. And then the little red patches there are the other rhyolites. There's some smaller outcrops, too small to show on the map, but these are the major outcrops. And where there's kind of a triangular shaped thing there of red, that's where we are right now.
Huh.
And there's a fault on the west side of this rhyolite called the Blue Creek Canyon Fault, which is a splay off the Mears. And as you can see, the Mears is going west-northwest or northwest, and the main Mountain View Fault there is mostly the same trend. The Blue Creek Canyon and Fault is, I guess, probably the largest fault between those two really gigantic faults, and it makes this anomalous bend to the north, and the road's more or less following it. The road's following a valley that's following the fault, and it's one of these Pennsylvanian faults that were developed. They were developing when the Aulacogen was being inverted in the Pennsylvania, and everything was being reverse faulted or thrust up onto the developing Anadarko Basin. And this is a transpressional structure for sure. The presence of this fault was one of the arguments about transpression here. It does have a reverse component in this direction. There's about 900 meters of stratigraphic offset across the fault right in this area, but there's also, it's an oblique slip at the same time, so there's a strike slip component. In fact, it's one of these restraining bends where this is left lateral motion along the Mears Fault, and this fault is coming up like that, so the left lateral strike slip is going right into it. So you get this thrust that's bringing the rhyolites on top of the really strongly deformed Cambrian Ordovician sedimentary rocks on the other side of the road. And as a result, this is the largest exposure of rhyolite that we have in the Slick Hills. But let's go back to this map. So you can see we're on the second largest patch of red. And then if you go further, you may be able to see two smaller patches of red. The larger of the two smaller is Valley Mountain and vicinity, and that's a very famous section. That's the one that Tim Denison discovered and proved that the Carlton rhyolite was really extrusive. But because most of you may have heard that at the top, before that, a lot of the workers out here thought that the Fort Sill rhyolite, the Davidson, and this stuff out here, they were all really fine-grained granites, basically, granifers they called it, but they thought they were high-level intrusive sheets. And Tim Denison went out to Valley Mountain, as I remember the story, and found some bedded tuffs. And reasonably enough inferred those weren't intrusive. And from that, he was able to measure a whole section of rhyolite out there. They measured a section about 2,500 feet thick.
Something like that.
And they identified a whole number of different flows. It's a really nice piece of work. In fact, the first time I had a graduate student working on these rocks, we met Tim here. I think it was 1999 maybe. And he spent the whole day with us, walked us over the whole section. It was just a great day. Didn't even bring lunch, but he ate, I gave him a few nuts or something, you know. It was a wonderful day, but he walked us through the whole section. Now our interpretation of flow boundaries has changed since then. We don't recognize so many flows. Our interpretation is that all the flows that these guys showed, and if you look at that 1964 bulletin, they've got a beautiful measured section. But what they were calling different flows, we're calling different zones within thicker flows. The field work those guys did, or Tim did, is spot on. And you want to see a contact between one of these zones, it's right where they show it, but my interpretation is different. But it's all part of the same story. So that's the thickest section. In fact, we believe that there's a few smaller hills further west that are part of the same coherent package. So we think the total thickness out there is about 2 kilometers of rhyolite, but a lot of it's covered. And I'm not sure what's in between the rhyolite where it's covered, but the exposed rocks are about 2 kilometers, which is the maximum known thickness of rhyolite so far, stratigraphic thickness. But these flows these outcrops are more extensive here. And you can see on this map, this is a map that my graduate student Chris Phillips did in 2002 for her master's. And you may be able to see bands of different color going that way. You may be able to see the Blue Creek Canyon Fault. And I should have stop 4 labeled on here. In fact, I do. You can see right there, stop 4 is where the rhyolite hits the road and ends. We're at that road cut. If you can you guys see that?
Yeah.
Excellent. Okay, so that's where we are, and it gives us just a little chance to look at a bit of the rhyolite here. So there's 7 flows that Chris was able to break out and map. And notice that as far as we can trace them, which is only like maybe 3.75 kilometers, of course they look really irregular, but they're just following the law of V's. All these drainages are draining south, and what you got here are a series of the rhyolite flows stacked one upon the next that are dipping at attitudes of about come on, where is it? I think it's pretty shallow dip. Sorry. That's 5. 16. 16. So it's a lot shallower than what we were seeing in the East Timber Hills. These are dipping shallowly about 16 degrees to the northeast, and so they're just V'ing upstream. So what you're seeing here is just a map pattern of 7 tabular flows as far as we can trace them. They're stacked one upon the next. There's thin interbeds between them. There's none of the thicker ones. The thickest interbed between them is maybe 1 meter or 2 meters thick at the most. And fine-grained vitric tuff, mudstone, stuff like that. Pepperite at the base of the flows. But this is giving us a bit of a window into what some of this volcanic field looks like. A major rhyolite lava eruption, one after the next, without very much sediment in between, never an unconformity or anything. The thickest flow here is about 230 meters thick. The thickest flow at Bally Mountain is 400 meters thick. That's what holds up the high peak of Bally Mountain. And the thinnest, we don't know, the lowest flow is the one we're looking at now. It's got this kind of purplish color, and the base there is covered, so we don't know the total thickness. It's got a minimum thickness of 50 meters, but we don't know how thick it was because we don't see its base. Now the top is overlain by blue. The top is a really neat angular unconformity. There's a slight angular discordance across it, but you can see that Chris's mapping shows that the flow boundaries are truncated at the unconformity. Meaning you can see that contact go right into it, meaning that there is an erosional, there's an angular discordance. And this is overlain by a beautiful transgressive sequence. It's a classic, almost textbook transgression. You have, this is Lower Cambrian rhyolite, and right above it you have Upper Cambrian Reagan Sandstone, so sometimes lost at that contact. And that contact represents it's the first record we have of the decay of the heat that was associated with this massive magmatic event. When the rifting was actively going on, you had a real steep walled rift, and after the heat went away, then you got the gradual slow thermal subsidence. So you get the classic rift basin overlain by the broad, much more shallowy, not using the right words for these sedimentary rocks, but the gradual thermal subsidence that follows the decay of the rift, right? And did I explain that right? Does that make sense?
Yeah.
And so, as that happens, the Reagan represents the first indication of this marine transgression that occurs here in the Upper Cambrian, and it's the same, it was the base of one of Sloss's, what's the Sauk sequence? Yeah, this is the base of one of Sloss's classic worldwide sequences, marine transgression. You can trace it all over North America, but we won't see it today, but those of you that hang on for tomorrow, we might be able to go look at that contact. It's kind of cool. So this is where the the rift is dyed. This is the first transgression. You get a little bit of alluvial material right at the base, reworking the rhyolite, and it grades rapidly up into what looks like shallow marine sandstone in the upper part of the Reagan. You go into the Honey Creek. The Honey Creek is the second unit above it, also upper Cambrian, well dated by trilobites. And even in the top of the Reagan, you start to get a lot of glauconite. It's a green sand, so it's beautiful transgressive stuff. Alluvial conglomerates and sandstones at the base, passing up into glauconitic cross-bedded sandstones, and then into glauconitic limestones of the of Honey Creek, and then into the Arbuckle group, Cambrian Ordovician platform carbonates, which stretch here from here to Scotland. The names change. It's probably the largest carbonate bank in the world, maybe. I don't know. It's big anyway. Interestingly enough, there's a lot of erosional relief on the unconformity, and my colleague Noel Donovan, who I should give credit for, he's been working out here for many years. He's now provost of the university. So he doesn't do as much field work anymore, but he's done a lot of the mapping out here, and one of the things he's done is he's mapped a whole series of paleo islands that project up from the unconformity, and he gets paleo islands of Carlton rhyolite projecting up to 300 meters into the overlying sedimentary rock. So you've got Carlton rhyolite overlain by Arbuckle group, and you can actually see these beds end against these paleo hills. It's just a beautiful story. He calls it the Southern Oklahoma Archipelago. I think he's got 7 or 8 of these rhyolite islands.
That's not what we're on here?
No, this is not a paleo island, because we're a ways from the sediment, but the first sediment you see there is Reagan. But there is some relief at that unconformity, so up there in places the Reagan disappears, and the Honey Creek will go right against these paleo islands. He's actually documented stromatolite communities and so on, and different kinds of fossil communities that change on one side of the islands versus the other. I can't remember which it is, but one side of the islands consistently has fauna that would be in quiet water, and the other side of the island always has all the shell debris.